In this video, I'm going to discuss about Cisco SD-WAN dynamic on-demand tunnels. This is a new feature introduced in release 20.3.1. This feature enables you to configure an inactive state of tunnel between the edge devices, reducing the performance demands on devices and reducing the network traffic. So this is the lab topology I have. I have VH1, 2, 3, 4 and VH22. When you onboard all these VHs and CHs, it comes with a full mesh topology, and each device establishes IPsec tunnel and also a BFD session with other VHs before it start forwarding the traffic between them. So this is my vManage. When I go into my VH1, for example, and when I click on the real-time say BFD sessions, you can say I have 5 branch devices, so I established BFD session with other 4, and also you will see the IPsec sessions. So there will be 4 IPsec sessions. So imagine you have like some 500 branch devices. You have to create 499 sessions with other branches in order to forward traffic between them. So that is the problem having full mesh. Your lower end devices performance might be impacted if you have like 1500 tunnels with other branch devices. So we go for the hub and spoke. But in hub and spoke, what happens? Let's say if I make VH22 as a hub router and all the other as a spoke. So the traffic, if I from VH1, if I want to reach the CH4, I have to send the packet to hub, and hub will forward back to your CH4. So instead of reaching directly, I extend one hop and then reaching to my CH4. So it while I have, instead of reaching directly, if I go via hub, slight latency increase you can see, when you have hub and spoke setup, and also the hub router will have more traffic and performance, because all the VHs will form a IPsec tunnel to the hub router. So with Cisco SD-WAN dynamic on-demand tunnels between the Cisco spoke devices, the tunnels are triggered to set up only when the traffic between the two devices. That is, let's say you have a hub and spoke topology, VH1 and VH22, that is your hub router, will by default have IPsec session. All the spokes will have a IPsec and BFD session only to our hub router. And let's say when you enable this dynamic on-demand tunnel feature in your SD-WAN topology, whenever the VH1 wants to send a traffic to, let's say, VH2, it will generate IPsec session and a BFD session between VH1 and VH2, and then start sending the traffic. After the flow of traffic between the device stops between VH and VH2, a user configurable inactive timer starts. And after the configured timer, the tunnel between the device is removed. The on-demand link between the two devices is then considered to be inactive. So in this inactive state, it does not use network bandwidth and does not affect device performance. So by doing this, it improves the performance, especially on less powered platforms operating in full mesh network. Also, it improves the latency in the hub and spoke deployment when on-demand tunnels are used between the spokes. So now let's see the dynamic on-demand tunnel feature and the process, how it works. Let's see a sample topology like this. We have branch 1 connected to the hub, that is edge 2, and then it goes to branch 4. Let's see, when there is no traffic passing between your branch 1 and branch 4, there will be no active tunnels between the edge 1 and edge 4. There is nothing but your branch 1, and branch 4 is your edge 4. And when a host behind your edge 1 sends a traffic destined to your host that is behind your edge 4, the first packet goes to your hub router. The hub router passes it to your branch 4 and then reaches your host behind the edge 4. So now your edge 1 provisions the tunnel and start the BFD session. Now the packet will come back from your edge 4. The reverse traffic will go to your hub and then hub forwards to your edge 1. So now your branch 4, that is your edge 4, also provisions a tunnel and it starts the BFD session. So at this point of time where both the edge 1 and edge 4 initiated the tunnels, the on-demand tunnel between the edge 1 and edge 4 will be coming up and the BFD session will also come up. Once the tunnels comes up and the BFD session also comes up, the packet will not go to your hub router. The packet will directly go from branch 1 to your branch 4. That is from edge 1 to edge 4. So until the traffic passing between your edge 1 and edge 4, the dynamic on-demand tunnel will be up, and in this future the traffic, that is the traffic going in on-demand tunnel, will be tracked. When there is no traffic passing between your edge 1 and edge 4, there is a on-demand tunnel timeout countdown that begins. By default it is like 10 minutes. For 10 minutes when there is no traffic, the tunnel will be active, and for 10 minutes continuously, let's say there is no traffic going between your edge 1 and edge 4, the timer stops and the tunnels will be it will be inactive, and the BFD session also will be coming down. So basically we create the dynamic on-demand tunnel only when the interstate traffic passing between your edge 1 and towards your edge 4. When there is no traffic, your tunnels will be teared down. That will be in inactive state. Now let's see how to configure this dynamic on-demand tunnel feature in our SDWAN setup. So now configuring the on-demand tunnel, it's a 4-step process. The first step is to configure the centralized control policy in your vSmart. Then you have to configure the OMP settings on your vSmart. Then hub device configuration, then go to the spoke devices. Let's see them one by one. So let's go to the vSmart controller configuration. This is the centralized policy that we need to configure. So we have to create a sequence, a control policy matching the route and matching all the branch sites, then accept it. Then we have to set a TLOC action backup and a TLOC list hub TLOC. Then we have to create one more sequence rule and match the TLOC, and action will be accept, and default also should be accept. These are just the site list and the TLOCs, and we apply for all the branches in the outgoing direction. So this actually ensures that the backup path through the hub for communication between all the spoke devices. The second is the step is the OMP settings. So the OMP settings we have to configure on the vSmart controller itself. Under OMP, the sent path limit should be 16. So the explanation given is like when on-demand tunnels are enabled, spokes use backup path through the hub. So a higher path limit is necessary. To accommodate this, increase the Cisco vSmart controller send path limit to advertise all available paths. Then third is the hub device configuration. That is a device that you decide as a hub or a backup route. We have to configure this. We have to configure under VPN 0. We have to configure the service TE. So this ensures that the Cisco SDWAN overlay management protocol on the spoke devices accept the backup path through the hub, which is being added as an intermediate path between the two spoke devices. Without this, the backup path through the hub would be considered invalid and unresolved by the spoke devices. So in the hub device, the traffic engineering services must be enabled. So the fourth step is the configuration on your spoke devices. So spoke devices under OMP, we have to enable the ECMP limit system. When on-demand tunnels are enabled, spoke devices create both direct and backup path. To accommodate the need for more path, increase the ECMP limit. And then we have to configure on-demand tunnels. We have to enable it under systems. So under systems, we have to enable on-demand enable and on-demand idle timeout. By default, it is 10 minutes, but we can configure in the range 1 to 65535. So on the spoke devices, enable on-demand tunnels at the system level. In case of multi-homed sites, enable on-demand on all systems in the site. That is, when you have a site with, let's say you have a VRRP site where you have an active and standby router. On both the routers, both active and standby routers, we have to enable the on-demand. So before we start configuring, let's understand the topology I have. I have one vBond, vManage and vSmart, and I have VH1, VH2, VH3 and VH4, and I have VH22. I'm going to keep VH22 as my hub or backup route, and I have VPN 10 in all the VHs, and 192.168.10.1 and 20.1, 30.1 and 40.1 in respective VLANs, and I have only one CH that is running Cisco IOS XE SD-WAN image. And before we start configuring, we have to make sure we upgrade our controllers, that is our vManage, vSmart and vBond to version 20.3.1, and the VHs also we upgrade to 20.3.1, and CH, that is Cisco IOS XE SD-WAN VJ, we have to upgrade to 17 release, because this feature dynamic on-demand tunnel feature is supported from that release. So these are the releases this feature is supported. Cisco IOS XE release 17.3.1.a and Cisco vManage release 20.3.1. So first we need to upgrade all our devices to the appropriate supported image. So this is my vManage console. First check the vManage. So vManage running in 20.3.1, and my vBond that is also running in 20.3.1, and my vSmart that is also running in 23.1. And let's go to the edge devices. So I have four VHs that is all running in 20.3.1, and I have one CH that is CSR 1000V that is running in 17.03.01. So now we have all our controllers and edge routers running in the supported software releases. Now we can start configuring the dynamic on-demand tunnel feature. So let's start with the first step, that is a centralized control policy. A central control policy we have to configure on Cisco vSmart must include the TLOC action backup. This ensures the backup path through the hub for communication between all the spoke devices. And the second is the centralized control policy must accept all spoke prefixes, and the control policy must accept TLOC of all spoke devices. So this is the policy example given, and now I'm going to configure this. So I'm in my vSmart, I'm going to policies. Under policies I'm going to give add policy. We need the sites, so I'm going to add a new site list to give all spokes, all spoke sites. So before we configure the site list, I want to show you the site that we have. Let's go to the main dashboard. So I have 5 devices. So I'm going to keep VH22, that is with site ID 22 as my hub. So I'm going to configure a site list with all the other VHs, that is VH1 with site ID 10, 2 with 20, 3 with 30 and CH4 with 40. So now let's go to our policies, add policy. I'm going to add only the sites. I'm going to add a new sites. So all spoke sites will be like 10, 20, 30 and 40. So my site is added, and we also need the TLOC of a hub that I already configured. So my TLOC IP for my hub router is 22.22.1, color is business internet and IPsec. So site is configured and TLOC is configured. I'm going to give next. So now click on add topology, go to custom control. So this is like So now let's click on the sequence type, select the root, add a sequence rule. So here we are going to match the sites all your all spoke sites, that is 10, 20, 30, 40. So I have selected all the sites. Now let's go to the action. Action will be accept, and first we click on the TLOC action. TLOC action, you have to select backup. Now next is TLOC. We have to select the TLOC list for the hub backup site that we have created. So I have selected all spoke sites and then clicked on accept and backup, TLOC action backup and TLOC list, the hub list. So that is the first control policy that we configure, sequence 100, match root, accept. Then second is to match the TLOCs. So before that I want to save this, save match and action. Now I have to again click on sequence type. This time I am going to select TLOC. Click on the sequence rule. I am not matching anything. I'm going to match all the TLOC. I'm going to click on action. Just click accept and then save match and action. Then the default action will be reject, that I have to make it accept. Save match and action. So this is for the root, matching the site, and then TLOC backup and TLOC list is also added. Okay, and save the control policy. Next, so here we are not doing anything. Then next, so here I give the name dynamic on demand policy. And I have to give a site list. So in the outbound side we have to give all spoke sites. All spoke sites I selected and then click on add. So now let's preview the policy before we apply. So this is my control policy, dynamic on demand tunnel 1 and sequence 1, match routes, all the sites, spoke sites, action accept, set TLOC action backup, TLOC list the hub backup site. Then another sequence, I'm matching the TLOC, all the TLOC and action accept and default action accept. This is just a list of all spokes. In hub I have only one TLOC, and we are applying for all the spoke sites in the outbound direction this control policy, dynamic on demand tunnel 1. Let's confirm the same in the example whether I configured correctly. So matching the route for all branches, set action accept and set action backup, TLOC action backup, TLOC list, hub TLOC. Then match TLOC action accept, default action accept, and applied in the outbound direction. You can save the policy. So now the policy is configured. The next step is the OMP setting on your vSmart. So under vSmart in OMP we have to give send path limit 16. So right now in my vSmart that configuration is not there. vSmart I have onboarded using a device template, so I have to create a feature template for OMP and then call it under my vSmart template, which you can see here. So I'm going to feature template. I have to select the device as vSmart, and then I have to click on the feature template OMP. Just name it vSmart OMP template. So everything is going to be same. The only thing I'm going to change is here the number of path advertised per prefix. I'm going to give globally 16. Rest everything I'm keeping as it is. I'm going to save this, and now I'm going to the device template, and under vSmart template you can see it is already applied to your vSmart. Going to edit this. So you can see OMP is using a default template. So now I'm going to call the vsmart OMP template which I just created. I'm going to update the vsmart. Let's see the config diff. You can see under OMP send path limit 16 is getting added. I'm going to push it now. So the configuration is pushed now. Let's verify in the CLI. Okay, now you can see the send path limit 16 in the vsmart. So the second step is over. So the third step is to configure the hub device. The hub device, I'm using a VH device only. So this is the config we need to enter. Under VPN 0, I have to configure the services T, that is the traffic engineering services. So in our topology, the hub router is VH22. I have already onboarded this VH22 using a separate device template. So you can see so DoD hub I given, that is attached to your device VH22. So I'm just going to edit, create a new VPN 0 template and then attach to this one. Going to feature template, add a new template for VH cloud. So I'm to configure a separate VPN template. So I'm going to just call it a DoD hub VPN 0 template. So you can see VPN 0 is already there. OMP IP route I need to configure. Default route I'll give a device specific. VPN 0 desktop IP address that we can add later. And then okay, now under services we have to choose TE, that is traffic engineering service, and then click on add. So under VPN 0 now we have added this TE, that is what we are supposed to do now, and rest everything is same. I'm going to save this. Now I'll go to my device template, the DoD hub. I'm going to edit this and I'm going to my transport and management VPN directly. So you can see under transport and management VPN I have VPN 0. I'm just going to change this template and configure the one just now, DoD hub VPN 0 template. Rest everything I'm going to keep as it is. I'm going to update this. So I have to edit this. So all the information is already there, only the VPN desktop IP address I have to give. So the desktop IP address will be 42.42.1.1. That is for our default route. So my interface IP is this 42.42.2 and 42.42.1.1 will be my desktop IP address. Let's see the config diff. Just want to make sure that service T is added. You can see it is getting added. I'm going to configure this now. So I'm in my VH22. Right now the config is not yet pushed. I'm just checking here. Okay, now we can see under VPN 0 service TE is added. So now our step 3 is completed. That is adding your VPN services TE. Now the fourth step is to configure your spoke devices. That is under the spoke devices, under OMP we have to give the ECMP limit 16. For all my spoke devices, I am running them through the template all VHs. So you can see all the VHs running in this template. I'm going to create a new OMP template, feature template, and then attach it to your existing device template itself. So now I'm going to configure a new feature template for OMP for all spoke routers. I'm going to VH Cloud, and under basic information I have OMP. So I'm going to name it all spoke OMP. So the grateful is on. So everything will be default. Only this ECMP limit I have to increase to 16, and then IPv4 I'm just enabling OSP of BGP. Rest everything is same. So our main goal is to keep this ECMP limit to 16. So I'm going to save this. So now I'm going to the device template. You can see all VHS template. So there I'm going to edit and add this OMP template. So you can see OMP, there is a old template here. I'm going to replace that with all spoke OMP, and then so we have to configure two things in our spoke routers. One is this OMP ECMP limit 16. The other thing is the on-demand feature we have to enable under systems. So under systems we have to enable on-demand, enable command, and on-demand idle timeout. So now I'm going to configure a system template for all spoke. This one is for VH Cloud, and then the system. So I'm going to name it all spoke system template. This is for the DoD, dynamic on demand. So everything I'm going to keep as it is default. Baud rate we give always 115200, and rest everything again is same. Under advanced, in the bottom if you see, you will have this feature enabled, on demand tunnel. So that I'm going to globally make it on, and the idle timeout is default 10. I'm going to reduce it. Let's say we'll give 5 minutes. So that's it. We have enabled on-demand tunnel and given the idle timeout, and then we save this. So now we go to the device template, all VHS, then we'll give the edit. So under systems there is already one feature template is there. I'm going to remove that with the all spoke template for DoD. We just created that, and also okay, OMP, it's not a change. Let's change this all spoke OMP, which we created earlier, for giving the ECMP limits to 16. So that's it. Let's update this on your spoke. Okay, so you can see green tick. Going to give next. Let's see what's it changing in VH1. So under systems, on demand enabled, on demand idle timeout 5, and under OMP we can see the ECMP limit 16 is there. That is for your VH1 and VH2. Let's confirm. So VH2 also you can see on demand enabled. VH3, let's confirm that. So VH3 configuration also we have this, and let's confirm the OMP also, ECMP limit 16. Okay, I'm going to push this configuration to the VHS now. the validation is success. It is getting pushed to our VHs. Now the config is pushed to all the 3 VHs. Let's verify in the CLI also. So now I'm in VH1. I'm giving show run. So under systems I have on demand enable, idle timeout 5, and under OMP let's confirm the ECMP is there, ECMP limit 16 is there. Same with VH2, on demand is enabled, OMP 16 is also enabled. I'm in VH3 now, on demand is enabled, and OMP 16 is also enabled. So CH4, on CH4 I'm going to configure via the CLI. Going to the config mode, going to systems, on demand. First I'm going to enable it, then on demand, idle timeout, I'm going to give 5. Then I will go under SDWAN OMP. We have that ECMP hyphen limit, going to give 16. That's it. I'm going to commit this. I'm giving show SDWAN run. Okay, so in this you can see the system config. We can see on demand enable, on demand idle timeout 5. Also under SD-WAN you can see the ECMP, under OMP ECMP limit 16. So with that we have configured all the 4 required configuration. So now I'm going to my vManage and activate the policy that I created for dynamic on demand. So this is the one, dynamic on demand policy. Now I'm going to activate this policy. So it's in progress now. Now the policy is pushed successfully. Let's go into our VHs. I'm in VH1. Let's check the show IP route. Let's match the OMP routes. So you can see I'm receiving let's say 192.168.20.0. I'm receiving from 20.20.20.1, that is my VH2, and also I'm receiving from 22.22.22.1, that is my VH22 actually. So if I see my topology here, you can see this is my destination IP 192.168.20.1, 192.168.20.0/24, that is this segment, that is actually coming from VH2. So that is getting advertised both from my VH2 as well as VH22, which is my hub backup router. You can see the same for from VH3 192.168.30.1. So 30 also you can see it learned twice. That is both from 30.30.1, that is my VH3, and also from VH22. And also the 60.60.1 is nothing but my the CH4, that is 40.1. So that 40.0/24 is coming from CH4 as well as from my hub backup. So there is one more command which give more idea on this. Show OMP routes received. So in the received you can see from 192.168.20.0 you are receiving from 22.22.22.1, that is showing under status CIR. CIR is nothing but chosen, installed and resolved. So the first packet will select this and it will go out of this. And from 20.20.20.1, that is the actual VH2 from where you are receiving these routes directly, that is showing IA. You can say it's on demand inactive. So when we initiate the traffic, when it becomes active, you will see CIR under this 20.20.20.1. Also in current state, I just want to show BFD sessions. You can see the BFD session is formed only between my VH1 and my VH22, and also show IPsec outbound connections. If you see, there is only one connection, that is towards my 4242 1.2. that is nothing but my VH22 WAN interface IP address 4242 1.2. And also there is one more command, show systems on demand remote systems. You can see the on demand status is inactive with your 2020.1, that is your VH2 site ID 20. So 22 we are not forming any on demand tunnels, so that is showing no. So with 30 we have on demand, that is showing yes, and that is inactive. And with 40 I have on demand yes, and also the current status is inactive. So now I'm going to initiate a ping from my VH1 towards my let's say VH2, though both are actually spoke devices, and I'm going to ping from 192.168.10.1 towards 192.168.20.1, and let's see what is the current status in VH2. Just want to confirm that. Show BFD sessions. So again, VH2 also have BFD session only with VH22, the hub router. Show IPsec outbound connection. You can see there is only one connection now, and also show system on demand remote system. So towards VH1, the site ID 10, that is 10.10.1, it's showing inactive as of now. So now I'm going to initiate a ping from my VH1, ping 192.168.20.1 under VPN 10. That is this IP 192.168.20.1. Okay. Okay. Now let's see whether our on-demand tunnel status came up. Show system on-demand remote status, and you can see with the site ID 20.20.1, that is my VH2, the tunnel status became active, and immediately you can see show BFD sessions. You can see I have created a BFD session towards my 4040.1.2. there is nothing but my WAN IP address of VH2. And also one more command, show IMP routes received. I have to just reduce this font. So now you can see for 192.168.20.2, so earlier it was showing CIR here. Now for VH2 TLOC it is showing CIR. So right now it is directly taking this path, so that you can see here. For other spokes like 30 and 40, you can see still it is showing IA, because we have not initiated any traffic towards that. Let's check the same in VH2 also. So you can see VH2 also towards VH1 it is active, and also you can see two IPsec connections. So that is from 4040.1.2 to 3030.1.1. that is from this 4040.1.2 WAN IP towards 3030.1.2. a IPsec session is established. Show BFD sessions. You can say BFD session also initiated too. Now let's do from now if you see this command, you can see the timer is kicked in. Right now there is no ping going on, so the timer is kicked in. We have kept like 5 minutes, so 300 seconds was the default timer. So it is once it becomes 0, the status become inactive, and the IPsec session and BFD session will go down. So right now there is no traffic going, so the inactive timer will soon kick in once the idle timeout expires in 71 seconds. And till the time, you can see the IPsec connection is up, and also the BFD session is up towards my that is from my edge 1 to my edge VH2. So once the idle timeout becomes 0, this BFD session and the IP section will be down between my VH1 and VH2. That is the first one, 20.20.20.1. This 40.40.1 IP, 40.40.1.2. So another 22 seconds it will be going down. The status will become inactive. So in another 2 seconds. Okay, now it is in inactive state. Let's check the IPsec connection. You can see the IPsec connection towards my VH2 is down, and let's check the BFD session. The BFD session also. So right now I have IPsec and BFD sessions only between my VH1 and my hub backup router, that is VH32. That is with 42.42.1.2. This one, 42.40.1.2. So right now again all the tunnel status is inactive now from my VH1 to VH2, 3 and 4. Now let's do a trace route from my VH1 and towards my CH4, and let's see what happens. Trace route VPN 10, and then the IP address is 192.168.40.1. that is from VH1 I am tracing to 192.168.40.1, this IP. So as you can see, the first packet goes to my 172.68.10.1 and then goes to 40.1. there is nothing but my hub router 172.168.10.1 IP. So the first packet always goes to my hub and then goes to my CH4. So now let's see the second packet. So you can see the trace route directly goes to 40.1. So after that, whenever I do a trace, it will go to 40.1 directly. And if you check the show system on demand remote system status, you can see it is active with the site ID 40, that is 60.60.60.1.1, and that is active now. Also now if you check the BFD session again, you can see the BFD session is established towards my 60.60.60.1, and also IPsec session connection is established towards 60.60.1, that is 60.60.1.2 IP, that is the WAN IP or CH4 60.60.1.2. Now let's check in CH4 also. So the command is show SDWAN system on demand remote system. So now if you see only with site ID 10, that is my VH1, the status is active now. And here also if you check show SD1 IPsec connection, you will see two connection, one with the hub router and one with your VH1, and also the BFD session. So BFD session also with the hub and also with my VH1. So earlier when I checked, it was showing only with my hub router. And if you see, there is no packet coming in, and the timer would have kicked in already. And you can see it's 226. And here also the command to check show SD1 OMP route VPN 10, if you give, you can check that. So for 192.168.10.0, so the CIR comes from 10.10.10.1, that is my VH1 TLOC, and since CIR is there, it will be directly going to that VH1. CIR nothing but chosen, installed, resolved. And you can see from CH4 for 20.0, you can see CIR is your hub. So that's why the first packet always goes to the hub. And you can see from VH2, from which actually you're receiving this packet, it's showing IA, that is on demand inactive, because there is no traffic passing between them. So right now in our topology, from VH1 towards CH4 we have active tunnels. Let's check the same in our vmanage. Let's go to monitor networks, then I select a VH1. From VH1 real time, if I go, let me check the BFD sessions. You can see it is established towards your SSD60.1, that is nothing but my CH4, and also the IPsec outbound connections. That is also only between my local router towards my hub and then to a CH4. We can also check the tunnel status under WAN. Click on tunnels, and in the chart option click the drop down and select the option on demand tunnel status. You can see whenever the tunnel goes active, and you can see it goes inactive. So in this section it's showing inactive. So whenever basically it gives you the status when the tunnel between which router it goes active and inactive. So now I'm in CH4. You can see the timer is getting expired. Yeah, so now it is become inactive. Let's say VH1 also. So there is no IPsec. I mean the IPsec connection between the VH1 and CH4 gone down. Now the IPsec session is only between VH1 and hub router. Also the PFD session. Now if you see in the vmanage also, I'm in my VH1. So the IPsec tunnel, you can see it's up only between my VH1 and VH22. For others it is showing down. So that's the procedure how you configure the Cisco SDWAN dynamic on-demand tunnel establishment. And if you see from right now, there won't be any. So everything is inactive now. Let's say when I ping all the IPs 192.168.10.1, VPN 10. Let's say I ping 20.1. Now I ping 30.1. I'm just initiating a ping between all the branches so that I'm bringing up all the tunnels. So now you can see all of them are active, and you can say it creates a IPsec session with all the other branches. So from VH1 I initiate a ping to all the other VH2, 3 and 4 other spoke routers, so I can see the outbound IPsec connections with all the others. Now let's check in VH2 IPsec session. I can see it's forming only with my hub and also with my VH1, because I not initiated ping with the 30 and 40 IPs. With that we come to end of the lab demo video about how to configure Cisco SD-WAN dynamic on-demand tunnels. So like how we saw in the sample topology, we made VH22 as a hub backup router, and all other routers like VH1, 2, 3 and 4 as spoke, and we managed to configure on-demand tunnels between them. That is, we configured inactive tunnels between these spoke devices, and whenever there is a traffic coming from VH1 to 2 or 4, the tunnel status from inactive to active, it changes, and then the traffic directly goes between the spokes. And when there is no traffic, the idle timeout starts. After the idle timeout, it again comes back to the inactive state. Share this video with your friends and colleagues who are interested. Also, don't forget to subscribe to the channel. Have a nice day.